Hello friends, welcome to the session. In today's session we will be continuing doing the questions of AIEEE 2009 mathematics session. This is the third problem solving session for AIEEE 2009. The first question says that let A, B and C be such that B times A plus C is not equal to 0 if the determinant A minus B, C, A plus 1, B plus 1, C minus 1, and similarly the third column is there, plus another determinant is given equals to 0, then the value of n is. So we need to find the value of n. So friends, let us do this question on the whiteboard. So let us write the determinants first. First determinant is A plus 1, A minus 1, minus B plus 1, B minus 1, and C minus 1, C plus 1. And another determinant, the second one is this one, A plus 1, B plus 1, C minus 1, the first row. The second row is A minus 1, B minus 1, and C plus 1. And the third row will be minus 1 to the power n plus 2 times A, minus 1 to the power n plus 1 times B, minus 1 to the power n times C. Now what we will be doing, we will be focusing on this determinant first. Let us name these determinant. Let this be the D1 and this be the D2. So let me write this determinant D2. So D2 equals to A plus 1, B plus 1, C minus 1. Rather make some space so that we can write it properly. A minus 1, B minus 1, C plus 1, and minus 1 to the power n plus 2 times A, minus 1 to the power n plus 1 B, and minus 1 to the power n times C. Now we know that minus 1 to the power n plus 2 can be written as minus 1 to the power times minus 1 whole square, that is equals to minus 1 to the power n. Similarly, minus 1 to the power n plus 1 can be written as minus 1 to the power n times minus 1 to the power 1, that is equals to minus of minus 1 to the power n. Therefore D2 will have now form something of this manner, that the first row will be unchanged, the second row will be unchanged, but the third row will change. The second row is again the same thing, A minus 1, B minus 1, and C plus 1, but the third row will now turn out to be minus 1 to the power n times A, minus of minus 1 times n B, and minus of 1 to the power n C. So we can see that minus 1 to the power n is present in all the terms of the third row. So we will take this thing outside the determinant. So our determinant now turned out to be minus 1 to the power n, and now inside the determinant the things will turn out to be A plus 1, B plus 1, C minus 1, A minus 1, B minus 1, C plus 1, A minus B, and C, because we have taken out minus 1 to the power n. Now what we need to do, we can transform this determinant in the form that we are exchanging the rows with columns. So our determinant will turn out to be minus 1 to the power n, and now the determinant will look like this form. We can replace this this column with the row 1, or we can interchange the rows, that is row 1 and row 3 are interchanged. If this happens, then there will be a negative sign with the given determinant, because we know that whenever one row is exchanged with another row, then the sign of determinant changes. So if we do like this, we get A minus B C. The second row becomes as it is, that is A minus 1, B minus 1 and C plus 1, and the third row will become A plus 1, B plus 1 and C minus 1. Now what we can do, we can interchange these rows also. So if we do this, then again a minus sign will be introduced, so that will make this negative sign a positive sign. So our resultant determinant will be equal to, as the space is very less, so I will be writing in very compact form. Please try to grasp from here only. So this minus will now multiplied with another minus, so we will getting a positive sign, and minus 1 to the power n will remain as it is. So the first row will be A minus B C. The second row will now turn out to be A plus 1, B plus 1 and C minus 1, and the third row will now become A minus 1, B minus 1, C plus 1. Now we know that if we exchange the rows and columns with each other, then the value of determinant remains same. So I am doing it here. What I can see by doing this, minus 1 to the power n, and the determinant will take this form. The first row will become the first column, that is A minus B C turned out to be the first column. The second row will become the second column, that will give A plus 1, B plus 1 and C minus 1, and the third row will become the third column, that is A minus 1, B minus 1 and C plus 1. Now if we check that after all these manipulations, how the D1 appears and how the D2 appears, we can see here now the D1 is exactly same as D2, but the only difference is that there is one constant is being multiplied, or not a constant, it will depend on the value of n, but something is being multiplied, that is minus 1 to the power n. So I am writing this whole thing over the next whiteboard, that is the D1 will be written as it is. We have not touched D1 in any way, so I am writing D1 as it is here. D1 is A plus 1, A minus 1, minus B plus 1, B minus 1, C minus 1, C plus 1, plus minus 1 to the power n, and the determinant is A plus 1, or rather we can say the same, A minus B C, A plus 1, B plus 1, C minus 1, A minus 1, B minus 1 and C plus 1. So these two determinants are identical, and the only thing which is there is exercise minus 1 to the power n, and their sum will be equal to 0 only if this turns out to be a negative sign. And we know that if this n is an odd number, that is if it is cube or 5 or any odd number, then only we will be getting minus 1 there, otherwise we will be getting plus 1, and if plus 1 is there, then we are not sure that it will become 0. It can be 0, it can't be, but if it is n is an odd number, then we are very much sure that their sum will turn out to be 0. So our answer should be any odd integer, and we can see here it is the option number C.